So in this video, we're going to talk about moles. We'll start off with the definition of a mole and what a mole actually is, and also some other definitions which will come in handy when explaining that. Then we'll look at the formulae used and some of the calculations that you'll need to know for A-level and other examinations. So first of all, what actually is a mole? What is a mole used for? Well, a mole, with the units mol, is actually the way chemists measure an amount of substance. This is because if you did it individually by an atom, there's loads of atoms. You can't say, oh, I reacted 2 million atoms. That's just pointless. You'll be writing numbers all day long when you're talking about reacting loads and loads of chemicals in a factory somewhere. So they use moles, which is similar to a baker using kilograms or somebody who deals with bottled drinks using milliliters. Chemists use moles. First of all, we just need to look at a couple of definitions. So Avogadro's constant is the amount of particles in 1 mole, which happens to have the number of 6.022 times 10 to the power of 23, which is a lot of atoms. Now you know why they use moles. The relative atomic mass is the weighted mean mass compared to 1/12 the mass of carbon-12. And what it means by the mean mass is the mean of all the isotopes. As you know from one of my previous videos, you get isotopes of different things. So carbon has an isotope carbon-12 and an isotope carbon-13. So the relative isotopic mass is the mass compared to 1/12 the mass of carbon-12 when you're looking at an individual isotope. So when you're looking at just carbon-13 or just carbon-12, for example. So a mole of a molecular compound contains 6.022 times 10 to the power of 23 molecules. It has a mass that is equal to its relative atomic or formula mass if you're looking at an entire molecule. This means, if we take carbon-12 as an example again, that 1 mole of carbon-12 will weigh 12 grams. And it's true for all atoms. So oxygen, which is 16, it will weigh 16 grams. Okay, so the units. What units do we use when we're doing moles calculations? So for mass, usually be grams, because most of the time in chemistry we're working with small quantities, so it's usually grams. However, the SI units, and sometimes if you're doing large scale things, it's kilograms. And what do I mean by an SI unit? Well, an SI unit is the units given to all things like mass, volume, pressure that has been internationally recognised, and it's a standard across the globe, so that's why people use it. However, like I said, in this case they don't use the SI unit always because we're talking about masses that are very, very small. Now volume. When we're talking about an aqueous state, usually it's centimetres cubed, which is the same as a milliliter, but centimetres cubed is more correct in terms of chemistry. Or sometimes we can talk about decimeters cubed, which 1,000 centimetres cubed is the same as a decimeter cubed. However, when we're talking about gases, we use meters cubed. And the SI unit for volume is actually meters cubed. So pressure, what do we use in pressure? We use pascals. Now pascals actually is an SI unit. Well, it's a combination of SI units, and that's what we use as pressure. Basically 1 atmosphere is approximately 1 times 10 to the power of 6 pascals. So that's why we use pascals. Concentration. So concentration is moles per dm cubed, and that's what you'll always use for concentration, moles per dm cubed in chemistry. And temperature, we use Kelvin, capital K. And Kelvin is used because absolute zero, which is 0 Kelvin, is the theoretical level that we can get to where there's no energy, no heat energy involved in a molecule. So molecules wouldn't vibrate anymore, they would just stand still, which we haven't been able to get down to. We've got close, but we haven't got to. So 0 degrees C, as you'll know, on the Celsius scale, is equivalent to approximately 273 Kelvin. It's actually 273.15 Kelvin. But for A level, you just need to know it to the nearest whole number. Okay, so they're the units that we'll use today. The next thing are the equations that we'll use. So there's 3 main equations that you'll you'll need to know when dealing with moles. So we've got number of moles is mass over molar mass, and I'll take you through what each symbol means in the next few slides. But this is usually used when you have a solid. This next one is number of moles is concentration times volume over 1,000. This is usually used for aqueous samples, and PV equals nRT. This is the ideal gas equation, and as it's in the name, we usually use it for gases. So if we look and break down the equations quickly before we do some calculations, if you know what these are, feel free to skip to later in the video where you can actually have a go at some questions, and I'll take you through them if you get stuck. So the first one is N equals M over MR. So N stands for number of moles, M stands for mass, which is in grams, and capital M, little r stands for molar mass, which is in grams per mole, which, as we know, moles is also got the unit mol, mole. So like I said, we'll use this in solids because we're talking about the mass of a solid. Now the next equation is N equals C times V over 1,000. So again, N equals moles, given the unit mol, mole. C is concentration, which is given the units moles per dm cubed. And V is volume, and this case, because it's over 1,000, it's in centimetres cubed. If we had N equals C times V, volume would actually be in decimeters cubed, because if you remember the conversion, 1 decimeter cubed is 1,000 centimeters cubed. So if you divide it by 1,000, you can convert it from decimeters to centimeters cubed. And the final equation, which is the ideal gas equation, we have P, which stands for pressure, which is given you units pascals. B equals volume, which is, because we're talking about a gas, meters cubed in this case. N, again, the number of moles, given the unit mole. R is a constant, and it's written up here as 8.314 joules per Kelvin per mole. And T is temperature, which is given the units Kelvin, as discussed earlier. Now we're going to talk about some of the actual calculations. I've put 9 examples up here. Feel free to pause the video and have a go at the 9 examples yourself. I've put numerical answers down there just to check if you've got it right. And if you've got something that's very similar, for example here, 8.92 times 10 to the minus 3, you may have a periodic table that has more or less decimal places than the one that I've used. So if you get an answer that's very, very similar, chances are you've done the right method, just use a different periodic table. Right, if you've had a go at those, I'll now go on to the solutions for 1, 3, 5, 7, 8 and 9, purely because 2 is similar to 1 and some of the other questions are similar to ones that have already been done. So look at question 1. Now, calculate the number of moles you have if you have 40 grams of NaOH. So, because we're using solid, we want moles and we have grams, which indicates solid. We want number of moles equals mass over molar mass. Because we want to find out moles, we have mass, and we can get the molar mass by looking at a periodic table of this. So first of all, let's work out molar mass. So it's the molar mass of sodium plus oxygen plus hydrogen. Now if you look at a periodic table, such as the data sheet that you may be given in an exam, sodium is approximately, depending on which periodic table you're looking at, 22.99. So 22.99 grams per mole, plus oxygen, which is 16 grams per mole, plus hydrogen, which is 1. So we put that into the equation, so number of moles equals mass, which you've been given as 40 grams, over 22.99 plus 16 plus 1. Now when you put that into the calculator, what you find out is you get an answer of 1 mole. And that's how you get it. So we're looking at a solid here because you're using grams. We can get MR from that. We want to know moles, so therefore we use that equation. It's giving you an answer of 1 mole. The next question is question 3. Calculate the mass of NaCl if you have 4 moles of the compound. So we want to find mass, we can get MR from that, and we have moles. So we're going to use this equation again. N equals M over MR. So number of moles is mass over molar mass. Now we want to calculate the mass. So what we're going to have to do to calculate the mass is simple GCSE mass of rearranging. So mass equals number of moles times by MR. All I've done is times up the MR here. So now if we calculate the MR, we have sodium again, which is 22.9, and chlorine, which is approximately 35.5. So we put that into the equation, so we have mass equals number of moles, which is 4, times by 22.99 plus 35.5, and don't forget the brackets. So that gives an answer of mass equals 234 grams. Don't forget the units, as it's a mass, it's grams. That's how you get that. We use the same equation because we have mass, we can work out MR from that, and we have moles. Next question, question 5. Calculate the number of moles in 25 centimeters cubed in a 25 centimeter cubed solution with a concentration of 2 moles per dm cubed. So we're going to use this equation. Number of moles equals C times V over 1,000. We use this equation because we want to find moles. We know we have a solution, so that gives this equation, if you remember that, but if not, 25 centimeters cubed shows a volume, so we know we're going to have a volume involved. And we've been given a concentration, so we're going to have a concentration involved. Because it's centimeters cubed, we're going to have it as over 1,000. So number of moles equals concentration times volume over 1,000. So we put that in, we've got the numbers here. Concentration is 2, so 2.00, times by volume, which is 25.0, over 1,000. And when you put that into the calculator, you get 0.0500 moles. And we can put this answer to 3 significant figures because we have 1, 2, 3, 1, 2, 3 significant figures in the data provided. That's how you get that answer. Now we will look at question 7. Calculate the volume in centimeters cubed of a solution containing 2 moles and with a concentration of 5 moles per dm cubed. So we're asked to calculate a volume. We have a solution, we have the number of moles, and we have a concentration. And it asks specifically in centimeters cubed. So this all screams out the equation that we use for solutions, which is number of moles equals C times V over 1,000. And it's over 1,000 because it's asked in centimeters cubed. But first things first, we need to rearrange this equation because we want volume. At the moment it's in terms of moles. So to rearrange that, we divide by C. So N over C equals V over 1,000, and N over C times 1,000 equals V. So all we have to do now is, using the numbers given in the question, which I recommend underlining while you're reading through the questions, is just put them in. So number of moles, 2.00, over concentration, which is 5.00, all times by 1000. When you put that in the calculator, you get 400 centimeters cubed. Notice it's three significant figures again, because we've got 2.00, which is 3, and 5.00, which is 3 significant figures. Question 9. So this is one of the more complex questions you'll get in, say, an A-level exam. So here, if 1 kilogram of an atom is heated to a temperature of 1000 Kelvin in a vessel of 3.616 dm cubed, reaching a pressure of 0.1 atmospheres, work out which atom is used. First things first is, we haven't got everything in the units that we want. So 1 kilogram, so we have a mass, which is 1 kilogram, which is equivalent to 1000 grams. We have a temperature of 1000 Kelvin, which is exactly what we want, which is good. We have a vessel of volume 3.616 decimeters cubed, which is good. Or that should actually say meters cubed, as it's a volume of gas. That should say meters cubed. So you have a volume of 3.616 meters cubed, reaching a pressure of 0.1 atmospheres, which is equivalent to 0.1 times 10 to the power of 6, which is equivalent to 1 times 10 to the power of 5 pascals. So first things first, we need to rearrange this equation PV equals nRT, because we're talking about gases and we have M, T, V, P, things like that. So that's the only equation that has all those in. But we want to find out what atom. So to find out what atom it is, we need to use molar mass. We need to work out the molar mass. How do we work out molar mass from here? Well, you may remember number of moles is the same as mass over molar mass. So what we can do is actually change this equation around to, instead of number of moles, we could put mass over molar mass times by RT. So all I've done is subbed in the n for mass over molar mass. They're equivalent. So now we can rearrange this to get molar mass on itself. So we can divide through by, well, times by through by mR first. So mR times by P times by V equals mass times R times T. All we've done is just times the mR over there. Then we can divide through by PV. So we've got mR equals little m RT over PV. And what we can do, we've got all these units up at the top here that we just worked out, we can just put them all in. So mass, 1000 grams, times by R, which is 8.314, again that will be given to you, times by temperature, which is 1000 Kelvin, all over pressure, which is 1 times 10 to the 5, times by the volume, which is 3.616. So put that into the calculator, and that gives us a molar mass of 22.99 grams per mole. And as we have that unit, and as we've worked out molar mass, you know the molar mass of a substance can tell you what substance it is. And if we look on the periodic table, what atom has a molar mass of 22.99, or approximately 22.99, depending which periodic table you're looking at? Well, when we look in there, it's actually sodium. Sodium has a molar mass of 22.99, meaning that is your answer. The atom being heated is sodium. That's all for today's video. I hope you enjoyed. Please like and subscribe for more. Thank you.